Hey there, rock breakers enthusiasts! Today we're delving into the fascinating world of hydraulic rock breakers. These powerful machines are a sight to behold, capable of shattering through solid rock as if it were mere paper. But what makes them so formidable? What's the secret behind their incredible strength and efficiency? Well, it all comes down to the magic of hydraulics, a principle that's been harnessed by engineers for centuries. In this video, we're going to take you on a journey to the heart of these machines, from the pressure-driven hydraulic power that fuels them to the impact mechanism that delivers the final crushing blow. We'll also discuss the role of the chisel or moil, the control mechanisms, and the wide range of applications and benefits of these mighty tools. So buckle up as we uncover the principles behind hydraulic rock breaker workings and explore the science behind their incredible strength. Hydraulic rock breakers operate using the power of hydraulic fluid under pressure. This may sound simple, but there's a lot happening behind the scenes. At the heart of every hydraulic system, you'll find a pump, valves, cylinders, and of course, the hydraulic fluid itself. Let's break it down a bit. The pump is the workhorse of the hydraulic system, responsible for creating pressure by moving the hydraulic fluid. It's like the heart pumping blood to keep the body functioning. Next up, we have the valves. They control the flow and direction of the hydraulic fluid, acting like traffic officers directing the flow of vehicles on a busy road. The cylinders, on the other hand, are where the magic happens. They convert the energy from the hydraulic fluid into mechanical force. Think of them as the muscles flexing to lift a heavy weight. And finally, we have the hydraulic fluid. This is the lifeblood of the system. It transmits the power from the pump to the cylinders, facilitating the movement of the rock breaker. Now you may be wondering where the excavator comes into play. Well, the excavator's hydraulic system is what provides the necessary power to operate the rock breaker. It's like the battery powering your remote control car. The combination of these elements enables the rock breaker to exert powerful force onto the rocks, shattering them with ease. So next time you marvel at a hydraulic rock breaker in action, remember it's all thanks to the power of hydraulic fluid under pressure. The excavator's hydraulic system provides the necessary power to operate the rock breaker. The heart of the hydraulic rock breaker is its impact mechanism, typically a piston driven by hydraulic pressure. Now let's dive deeper into this. The piston is a crucial component in the rock breaker's impact mechanism. It's the piston's motion and velocity that determine the power of the blow that will shatter the rock. How does this work? Well, imagine the piston as a heavyweight boxer's fist. When the boxer throws a punch, the power behind that punch depends on the speed and force of the swing. Similarly, the piston in a hydraulic rock breaker delivers a powerful punch to the rock, driven by hydraulic pressure. But what creates this pressure? The answer lies in the hydraulic fluid. This fluid is pumped into the cylinder housing the piston, and as the fluid enters the cylinder, it creates a strong pressure. This pressure pushes against the piston, forcing it to move rapidly. Just like our boxer's punch, the piston's movement is swift and forceful. This rapid motion transforms the hydraulic energy into mechanical energy, which is then used to generate high-impact energy. The beauty of this system is its efficiency. The hydraulic pressure allows the piston to move quickly and deliver a powerful blow. Yet it also allows the piston to retract swiftly, ready for the next blow. This quick retraction and subsequent strike create a repetitive, high-impact action, capable of breaking through even the toughest rocks. To visualize this, think of a jackhammer pounding away at the pavement. It's the same principle. Rapid, high-impact strikes breaking down the material. This is the power of the hydraulic rock breaker's impact mechanism. It's a finely tuned system of pressure and motion, delivering incredible strength and efficiency. So the next time you see a hydraulic rock breaker in action, remember the piston, the heart of the machine, rapidly moving back and forth, powered by hydraulic pressure, delivering powerful blows that shatter rocks into pieces. When the hydraulic fluid is pumped into the cylinder, it forces the piston to move rapidly, generating high-impact energy. And that, my friends, is the essence of the impact mechanism in a hydraulic rock breaker. At the end of the piston, there's a chisel or moil, the part that actually strikes the rock surface. This is where the magic happens. This is where the strength of the hydraulic rock breaker culminates and propels us into the world of rock-breaking action. The chisel or moil does more than just hit the rock. It's a finely engineered tool, designed with precision to deliver the maximum impact. You see, the rock breaker is like a boxer. The piston is the boxer's arm. The hydraulic fluid is the boxer's muscle. But the chisel? That's the boxer's fist. It's the point of contact that delivers the knockout punch. In the case of a rock breaker, the chisel or moil is designed to concentrate the impact force onto a small, defined area. It's not about mindlessly smashing into the rock's surface. It's about applying a precise, concentrated force that penetrates the rock and causes it to fracture. Like a sculptor chipping away at a block of marble, the chisel or moil chips away at the rock, delivering powerful precision blows that shatter the toughest materials. It's a process that combines brute force with finesse, and it's all thanks to the clever design of the chisel or moil. The shape of the chisel is also crucial. Whether it's a pointed moil for breaking through hard, compact rock, or a flat chisel for cutting through layers of softer material, the tool is always tailored to the task. So, the next time you see a hydraulic rock breaker in action, remember the chisel or moil. It might seem like a simple piece of metal, but it's a vital component that transforms the raw hydraulic power into a focused force capable of breaking through rock. And that's the beauty of engineering. It's about understanding the principles of physics and applying them in innovative ways to solve real-world problems. The hydraulic rock breaker is a perfect example of this. It's a marvel of modern engineering, and at its heart is the humble chisel or moil. The chisel is designed to concentrate the impact force onto a small area, effectively breaking the rock. Operators control the hydraulic rock breaker using the excavator's controls. Now, if you're thinking that operating such a powerful machine is a complex task, let me reassure you, it's not as daunting as it may seem. In fact, the control mechanism of a hydraulic rock breaker is designed to be straightforward and intuitive. At the heart of this control mechanism are two important parameters that the operator can adjust: the frequency and the intensity of the blows. Just like a drummer controls the rhythm and force of his drumsticks, an operator controls the hydraulic rock breaker's piston. The frequency of the blows is essentially how fast the piston moves. A higher frequency means the piston moves faster, delivering rapid-fire blows to the rock. This is particularly useful when dealing with softer materials that can be broken down quickly. On the other hand, the intensity of the blows refers to the force or energy behind each strike. A higher intensity means each blow carries more power, capable of breaking through harder materials. To picture this, think about trying to crack open a tough nut. A gentle tap won't do much, but a solid whack? That's a different story. Now, every rock is different. Different in size, different in hardness. So the operator needs to adjust the frequency and intensity to suit the specific rock. A larger rock or a harder rock might need a lower frequency, but higher intensity, focusing on power rather than speed. Conversely, a smaller or softer rock might be best dealt with a higher frequency and lower intensity, prioritizing speed over power. So it's really a balancing act, a game of precision and judgment. But with experience and understanding of the machine, operators can fine-tune these parameters to efficiently break down any rock that comes their way. And that's the beauty of the control mechanism of a hydraulic rock breaker. It gives the operator the flexibility and control to adapt to different situations, to tackle any rock, no matter how big or how hard. They can adjust the frequency and intensity of the blows to suit the hardness and size of the rock. Now that we understand how hydraulic rock breakers work, let's explore their applications and benefits. These powerful tools are not just about breaking rocks. Their usage extends across various industries, each exploiting their unique capabilities in different ways. First off, in the world of demolition, hydraulic rock breakers are the go-to equipment. They're used to break up concrete structures, rocks, and pavements, making them indispensable in tearing down buildings and other structures. Next, we have quarrying and mining. Here, hydraulic rock breakers play a vital role in primary breaking and secondary reduction of large rocks, making the extraction of minerals and other resources a whole lot easier. Moving on to construction, these mighty tools are frequently used for excavation, trenching, and foundation work. They're relied upon to clear the way for new buildings, roads, and other infrastructure projects. But it's not just about brute force. One of the key benefits of hydraulic rock breakers is their precision. Operators can adjust the frequency and intensity of the blows, allowing them to break down materials with surgical precision. This precision, combined with their high efficiency, dramatically reduces manual labor and project timelines. So, whether it's tearing down an old building, extracting valuable resources, or laying the groundwork for a new skyscraper, hydraulic rock breakers are hard at work, making our lives easier and our projects more efficient. Hydraulic rock breakers offer precise control and high efficiency, reducing manual labor and project timelines. And there you have it, folks. The principle behind hydraulic rock breaker workings explained. These powerful tools harness the might of hydraulic power, transforming it into a formidable force that breaks through solid rock. At the core of their operation is the impact mechanism, a piston driven by hydraulic pressure, delivering strikes with immense energy. The chisel or moil, the component that meets the rock face, concentrates this energy onto a small area, causing the rock to fracture. And let's not forget the control mechanism, allowing operators to adjust the frequency and intensity of the blows to suit the hardness and size of the rock. These mighty tools are indispensable in various industries for their efficiency and power. From demolition projects to quarrying, mining, and construction, hydraulic rock breakers are a testament to human ingenuity and the power of hydraulics. If you found this video helpful, don't forget to smash that like button and subscribe for more fascinating insights. Until next time, keep breaking barriers and rock on.